Welcome back to my desktop. Today, a quick look at what TopCat can do when you're looking into open clusters. And we're going to take a very obvious open cluster, the Pleiades in this case, and show you the various things that TopCat can do. First, we're going to use the VO menu and select Cone Search, which allows us to go out into the net and select one of the third-party registry tools that will allow us to search for data availability for cone searches, in this case the early data release 3 of Gaia, and tell it to find services, and it goes off and it does that. I'm going to select the ARI or Aries cone search service for Gaia EDR3 and select it. And then you need to give parameters to the actual cone that you're searching for or through. And I'm going to give it the Pleiades cluster and tell it to resolve the position of that cluster, and it does. You can enter Messier objects and similar. And it will give you the right ascension and declination in decimal degrees. And then you have to tell it how many degrees of radius you would like to search for. And be careful about this one, because if you input too great a radius of sky, it could return a very large table, which may not be what you want. Clicking OK on this, and it loads a new table, goes out to the internet, to Gaia, and pulls down the data, which it has done. You can double click on that and take a quick look at a table browser of the data that you've just downloaded, giving you the source ID and the Gaia designation, which are very similar, the right ascension and declination to the year 2000.0, and all sorts of other wonderful stuff, things like the parallax angle to the object, its proper motion in right ascension and declination, its photometric G mean magnitudes. It gives you all sorts of fun stuff. So we can close this. Let's play a little bit. In TopCat, you can project everything that you just found onto a sky plot, and you can zoom out with your mouse wheel and drag it around, and it shows you a virtual image of the sky with your selected stuff there. And of course this just looks like a bunch of stuff, which is true and interesting, kind of cool. But we're also interested in other types of things here. We would like to find some of these objects in a way that gives us a little bit more information. In other words, we'd like to pick out just the stars and the Pleiades, which is kind of neat. If we go to the form and select form, let's create a sky vector form here, and then let's choose for the coordinates its proper motion in right ascension and its proper motion in declination, and it will change all of our objects to actual vectors of proper motion in the sky, which is really kind of cool. And as you move around, you can see that there's one really obvious thick group here, and you know, let's just bet that that's the Pleiades cluster, but let's check it out. We can also then go to the plane plotting window again, open up another one, and one of the great things about TopCat is that all of the windows are interconnected. Changes in one will help make changes in the other. And so in this, we're going to change this to proper motion and right ascension versus the proper motion and declination on just a 2D plot. And sure enough, most of these things are going to be centered around having 0 milliarcseconds per year of proper motion. But if you zoom in, you'll see that there's a group that stands alone over here, and it's not like all the rest of the stars that are, or objects that are at 0, 0. This one's way out here at like negative 50, 20. Let's select these. There's an option up here, draw a region on the plot to define a new row subset. And what this does is allows us to draw a region around the object of interest or objects of interest. And by clicking that button again, it creates a new data subset. And we're actually going to call this M45 proper. So this is actually the stars of the Pleiades cluster. Turns that group blue, and over here it also generates it as a color corrected set of vectors for you. And we were right about our guess that that thick group was the Pleiades, which is kind of cool. I'm going to leave that open so that you can think about that. Another thing you can do, there's a histogram tool. There's this tool up here in TopCat proper. It says plane plotting window configured for convenience when plotting histograms. And clicking that, it just brings up this giant histogram of right ascension and declination of all the targets in your space of sky. That's really not what we're after. What we're kind of looking for here is a parallax histogram, and it does it again with all the objects in your entire data set. But we just want to look at the subset of M45 proper, and so we turn off all. Sometimes can be a little tricky, and just leave M45 proper selected, and sure enough it'll give you the centralized parallax for the objects that are just in Messier 45, and from that you can calculate a distance, 1 over parallax angle, etc. And a reminder, this is giving to you in milliarc seconds, so you can do that math, and it's usually very accurate. So that's one other option you can do. And something else you can do, which is also equally fun, is go over here and look at the data again. And this time we're going to try to get a color magnitude diagram going. So on the x-axis, we're going to do a really nice photometric filter choice here, where we are going to look at, see if we can find it. Sometimes these things are a little bit challenging. You have to know exactly what you're looking for. There it is. Blue minus red for your X, so that's a color temperature. And then on your Y, we're going to give it the mean photometric G magnitude mean. And sure enough, you get a color magnitude diagram, but it is inverted. Click on axes and flip your Y-axis, and that looks better. And now you're feeling pretty good, except that's every star in your entire data set, not the subset of M45. So if you want to see that stick out, just check it. And now you see M45 projected in blue. And you can uncheck the rest, and now you have a proper color magnitude diagram for all the stars that were located in this region for proper motion, which sets them apart. That's pretty cool at that given parallax angle too. Now at this stage you're thinking, okay, I'd like to be able to save this work, but one thing I recommend doing right now is going over here, and there's this display row subsets window. The row subsets window allows you to select your subset of curiosity, all the objects that are in M45 proper, not everything, just M45 proper. And then there's this button here that says create new Boolean column from selected subset. You can say is member of M45, and this will create a new column for your data set with a checkbox, Boolean yes or no for is member of M45. You select yes and you're good. And to check that, of course, you can always go back and look at your table, look at the very end, and you'll see a new column here is member of M45, and I'll leave that unchecked, but as you scroll down you will see members of M45 and all with checkboxes in them, which is great. And if you're curious about why that's important, that's so that you can go and save this, and if you save it as a comma delimited file, a CSV file, and tell it where to go, it's going to get upset. You have to use the file browser for this. Navigate to where you want it, give it a name, make sure it's a CSV file, and save it. You can then open that in Microsoft Excel and then delete everything except those things that have a check, a Boolean check for membership in Messier 45. So that's how you find some basic raw information, some calculated information, and isolate these values to create a new table from. And then you can just re-import that table at any moment's notice and use that. Something else people may not know here is that you can also have another cone search. There's no reason why you can't just do all this again, but with other objects. For example, M35 is a perfectly good object to search for. I'm not sure why it's doing that. M35, tell it to resolve. It goes off and it resolves it. Say OK, and it goes and it drags down another table that contains all the information for the object Messier 35. And you can do all these things again just with Messier 35. In this case, let's take a look at a plot of it, and we're going to look at the proper motion in right ascension and the proper motion in declination. Bring up that plot again and notice everything near 0, 0. But as you zoom in, you may be having trouble seeing a second membership of an open cluster, but sure enough, look at this. There are two of them. There's one here, and there's one over there. This is kind of a nice thing to show students. It allows them to realize that there are multiple objects in this view, and maybe they should go look at a photograph of the sky and realize that both M35 and there's also an NGC cluster nearby happen to be very close to each other. So yet another reason why the careful selection of narrowing down the diameter of the region of the sky that you're after can be helpful. Alright, that's enough for now. Thank you very much for watching.